Marang you indicate Baladu Wiradjuri Yinna. So good morning, my name is Kate and I'm a Wiradjuri woman. I'd like to acknowledge that I am currently standing on country that was never ceded. It's Ngunnawal, Ngambri and Narragain country. This is the second of two mini lectures, and this one is about freshwater quality. If you've already seen the first lecture, then you will know that I'm going to say something like, even though I discuss water availability and water quality separately, they're actually interconnected. And you might also remember in that other little lecture that I said it's not always sensible to make the distinction between environmental processes and human activities, because what we do does affect how the environment operates and can often result in far from ideal outcomes. So just to remind you, this mini lecture discusses freshwater quality. Water quality is not quite as easy to identify or define as water distribution or availability, and this as much reflects the diversity of uses of water as the properties that contribute to water quality. So for example, clear water is not always drinkable, as it may have pathogens that are invisible to the naked eye, such as E. coli, which comes from poo and can make people very sick. But some cloudy water may be safe to drink, as that cloudiness simply comes from fine clay particles. There are many activities that require what may be broadly known as clean water, so that's some sort of version of good water quality. For example, drinking water, stock or irrigation water, water for renal analysis or for making microchips, water for personal hygiene and water for recreational activities like swimming, boating, fishing. They all need some form of clean or good quality water. Yet, obviously, there are different standards of water quality required for each of these activities. Water for renal analysis and making microchips needs to be even better quality than the water we drink or wash ourselves with. Yet water quality for stock, irrigation and some recreational activities like boating, for example, don't need the same standard as potable supply, which is potable supply is water for drinking and personal hygiene needs. So that means there are many ways to classify the quality of water. The quality of surface water or domestic water, water found in households, is usually sourced from surface water. It is often described in terms of poor, fair, good or excellent. And in the mini lecture on water quantity, you met the term saline, so that is salty water. And salty water is classified to how saline it is, so how much salt is in that water. From brackish, where you've got fresh and salt water mixed, such as at a mangrove, to saline, and hypersaline, such as the water in the Dead Sea, where even if you try, you can't drown, you can't sink, or water that comes out of a desalination plant. Even household water use, so potable supply, can be classified differently once the water has been used. So if potable supply has been used for washing dishes or cleaning your clothes, it's then sometimes called grey water. And the water that we flush from the toilet is always called black water after it's been through the toilet system. So clearly there is some sort of continuum that can be regarded as clean water or good quality water. And so for this reason, it's usually better to think of water qualities in terms of fit for purpose, rather than simply being good, bad, or something in between. The aim of fit for purpose is to treat water to the quality that is required for the purpose that it's going to be used. So potable supply is fit for drinking, but not fit for renal analysis. The quality of potable supply is more than it's fit for irrigation or stock water. But potable supply is also a better quality of water than required for flushing toilets, which happens in most homes in Australia, which makes potable supply very unfit for a very common purpose. And unfortunately, there are many reasons why human systems and practices produce water for activities for which it is not fit for purpose. And this example is another example of how human behaviour influences natural processes. Lots of money, energy and space is used to produce potable supply, yet a lot of it is used to flush toilets. If water quality fit for the purpose of flushing toilets was used, dams could be smaller, for example, meaning less land and all that exists on it would need to be submerged. Conversely, dams might remain full for longer. This is an important consideration in places where extended dry periods are common. To help people treat and use water in a fit-for-purpose manner, many water quality standards have been developed. Standards exist for drinking water, for sewage treatment, for salinity, and recycled, bottled and tank water, and ship ballast water, for example. Drinking water standards are particularly rigorously monitored by water health providers and health authorities to ensure the old, the sick and the young, the very young, can drink safely. Almost all water used by humans for the activities we like to do almost always requires some level of treatment. Water treatment processes are either one or a combination of biological, chemical or physical processes. And for example, to treat sewage or drinking water, all three of these types of processes are required. Very small bugs, too small to see, are often in sewage treatment. Chemicals are either added or removed from both sewage and potable water, and the physical filtering of both sewage and potable water is generally the first step. My research currently looks at stormwater. So this is overland flow and storm flow funneled through stormwater systems. Widely regarded as polluted water, this water still experiences, by human design or environmental processes, some form of treatment. Gross pollutant traps, for example, filter the large pollutants such as shopping trolleys, bits of furniture or clothing, and large bits of plastic or polystyrene out of the water column. The polluted water is often discharged to less heavily modified stream systems than the concrete channels that they run through. At the discharge sites, biological processes such as nitrate fixing through plant roots or chemical processes such as the adsorption, where phosphate is chemically bound to inorganic particles. It is not uncommon for these biological and chemical processes to be overwhelmed at the discharge site by the volume of water. That is, the capacity of the environmental processes to account for human activity is inadequate, allowing polluted water to travel even further downstream beyond the discharge site. So I live in Canberra, which has an extensive stormwater system. Canberra is the largest urban area in the Murray-Darling Basin, and this polluted water generally generated in Canberra travels downstream towards nationally significant irrigation areas. As well as impacting human health and irrigation activities, poor water quality can be fatal for non-human life. The well-reported fish kills along the Barker-Darling and many other rivers over the last couple of years are a stark message about what happens when only basic human needs and the economic values of water quality are considered in water quality discussions. The reduced volume of water, both from the drought and the irrigation extraction, so a human activity, in the channel meant that the water had become too hot for the fish, and there wasn't enough oxygen for the fish to breathe. And while I haven't seen the detailed water quality analysis, I'm fairly confident that would have been a high level of agricultural effluent in the water column. So things like pesticides and herbicides, which damage quite severely fish physiology, particularly their gills and scales. Indigenous peoples look at water quality priorities very differently. For example, no Indigenous water science that I know has anything like storm water. To deliberately allow a water source to not only become polluted, but to remain polluted is totally unheard of. And I think this is for two reasons. The first being the point raised in the water availability mini lecture, where Indigenous people see rivers as their own living beings, and it's rude and disrespectful to knowingly pollute something living that also supports the life of humans and the more than human. The second reason is that Indigenous peoples recognise that fresh water is scarce, even without knowing that only approximately 0.4% of the Earth's surface water is fresh water available for consumption. They still knew that fresh water had to be conserved and used sparingly. Greed is generally not widely condoned in Indigenous land and water management practices. It's not just Indigenous peoples who approach water quality from outside the Western scientific perspective. I'm sure some of you watching this have been into a Catholic church and used the water in the font. This water is regarded as sacred as has been blessed by a priest. And using this water to make the sign of the cross is to protect that person against evil. Muslims also have water at the front of mosques. It is considered blasphemous to enter a mosque without washing at least your hands, face and feet. Buddhists also use water considered sacred in many ceremonies. Millions of Hindus bathe daily in the Ganga, the river Ganges, surrounded by visible pollution, which include the corpses of people and animals, and the invisible pollution from factories and irrigation to wash away their sins. All of these waters are considered sacred and are of the purest spiritual quality. But by modern Western standards discussed earlier in this lecture, none of this water is regarded as either good quality or fit for purpose. Yet these people will continue to use water in this and other socio-cultural ways without any regard to the standards set by health or economic criteria. In this mini lecture, the different standards for articulating water quality have been raised. What I hope you've come to realise is that the standards need to take account of what the water is used for, and that simply focusing on basic health and economic needs is not enough. It is not just humans that have need of appropriate water quality, but that humans do not only see water quality in the strict terms of modern Western science. I hope you recognise that both more than human and the social, cultural needs and practices of humans also need to be considered when thinking about water quality.